Okay, state the charge on the meson. Now, let's have a look. It's made of an anti-up and a strange quark. And if you look at your data booklets, you don't need to remember it, look at the data booklets, the charge is clearly given. So an up quark is given as 2/3. So an anti-up quark has to be the opposite, which is minus 2/3. The strange quark is given as just strange value, which is minus 1/3. Add them together, what do we get? Minus 2/3 plus minus 1/3 is going to give you a total of -1. The Feynman diagram shows the changes occurring during a beta minus decay. Be careful, yes, it's a beta minus decay. To be honest, the most likely questions are going to be beta minus or beta plus decay, and therefore should be fairly straightforward. These are obviously going to be your quarks, these are your quarks, here's your boson, lepton, and so we're going to look at what's most appropriate here. From your knowledge, we should know that a neutron is made of an up, down, down quark. A proton is made of two ups and a down. So a down is changing into an up quark. So straightforward there. What's given off? Beta minus, which is an electron, and an electron is a lepton, so it's E minus, that is an electron. What is the exchange particle? Well, for the conservation of charge, the exchange particle is going to be a boson. It's got to be carrying a negative charge, and the only boson with the negative charge is the W minus boson. So W minus boson coming in here, so minus going to minus, and then that balances. We don't need to worry about that, but obviously that's an anti-electron neutrino. A bit straightforward there, I think. All right. Explain why the mass of a carbon-14 nucleus and the mass of a nitrogen-14 nucleus are slightly different, even though they have the same nucleon number. Okay, well, it's already said that carbon-14 has undergone a beta minus decay. In other words, it's lost something. It's lost, as we can see, a lepton and an anti-electron neutrino. So that's got to come from something. Energy can be converted to mass, mass can be converted to energy. But we know that leptons have mass. So if mass has been lost, the mass automatically of the carbon-14, nitrogen-14 can't be the same. The products have mass, the products have energy, that energy and mass must come from somewhere. The nitrogen-14 nucleus has to be lighter than carbon-14 because those particles have been lost from it. So the products have both energy, they've also got the, be careful, if they've got energy, that energy's got to come from mass, so there's an energy mass equivalent. There's a mass defect or deficit, and that's due to the binding energy, and that's being converted to the energy of decay. So some comments here that indicate that basically leptons have mass, so you're losing mass, so therefore it's got to be lighter. Products have got energy, that energy has to come from mass, or you could look at it in terms of the mass defect or binding energy being converted to the energy of decay. And that's 2 marks for that. A little bit more complicated, logical, but it does need clear statements of what's going on there. Thank you very much.